All right, welcome. Let's get started. Okay, I see that many of you have your computers here today. That's excellent. I really appreciate that. It'll make it a lot easier for you to follow along. I think it'll make your class time more valuable if you've got a computer and can do the calculations. And let's look at these announcements here. If you can bring one on Wednesday, that would be great. And then this assignment that I've just given you is due on Friday. And that seems like a quick turnaround until you see that there's only 4 problems. So in comparison to this more lengthy assignment that you've just completed, I think these 4 problems will come pretty quickly, especially when you get the hang of Excel. So any questions about these announcements? All right. Now, one of the confusing things on the pre-existing Excel functions is that you have to put in a negative sign when you're specifying the amount inside of the function. And I want to explain a little bit more about the background of that. I demonstrated in class last time what you have to do to overcome it, but here's the why. When you are using those pre-existing functions like equals PV, Excel is assuming that you have some future value, for example, and you want to find out what is the deposit that would be required in order to make that future withdrawal possible. I mean, they could have assumed one of 2 things. They could have assumed, in other words, that the present amount is an inflow or an outflow. And I guess someone at Microsoft made the decision that most of the time when the function is being used, you have a known value that's one direction and the unknown that you're trying to find is the other direction. And so just by default, the convention built into the formula is that it's this view. It's that one of the amounts is a deposit and the other is a withdrawal. Really, most of the time, though, we're going to be solving for problems that look like this. We're going to be solving for some present value where we know a future amount, and we're going to have the same directionality of that quantity. And so if it is an inflow, like is pictured here, in the future, we're going to assume that we're going to try and find the present value of that by discounting it, but we're going to assume that it's still an inflow for most of the type of problem solving that we're using. And I guess maybe this goes back to the difference in how Excel is being used from accountants versus engineers. I'm not really sure why Microsoft made that assumption, but they did. So we have to put the negative sign to the built-in formula to overcome that. It's a small price to pay for being able to use those pre-existing formulas because they're awfully helpful. Let's just summarize what we saw before with the PV. FV is the same kind of idea, although obviously it's solving for a future value rather than based on a present value. Okay, so the form of both functions is you're starting with an equal sign to tell Excel that it's an equation that you're going to be doing. FV means find the future value. PV means find the present value. In these types of problems, you'll be having an interest rate, and you have to put it in as a decimal. And so if it's 8% interest, you need to put 0.08 in the first field. If you put 8, then it would think 800% interest. And your answers would be really, really strange for that. Now, N is just referring to the number of years. And it's pretty easy when you're finding the present value because it's just how many years away whatever row is from year 0. And what I mean by that is let's say that you have some amount in year 8 and you need to take it to year 0, N would be 8 for PV. So it's simple. The future value N values are a little bit more tricky because let's say that you're taking some amount from year 0 to year 8. Well, N would be 8 on the first row of your calculations because it's 8 years away. When you're going from 7 to 8, you're on the 7th row, but you're only moving at 1 year. And so in the handout I'm going to give you today for our in-class exercise, when we're doing future value type calculations, you need to change what the N value is going to be so that it is It's the number of years away from that future that you're trying to move it from. So it's how many years away from whatever is the end result to where you're moving it. You'll also notice here that we have the negative sign. Now, this double comma, does anybody remember why we put in 2 commas and skip over one of the fields? What's that? Okay, I think you're headed on the right track. What Excel is looking for in that field is what if it was an ongoing payment, several different times the same amount. So let me draw on the board here what I mean. If you had several payments, 1, 2, 3, 4. So I've done 4 amounts. They're all equal, and let's say it is $100 each. So if we wanted to find out what is the present value of that $100, what we could do is in the PV here, we could say whatever the interest rate is, and then we would say N, we'd put in the number 4 in the N field, and then in this third field, we would just put the 100, because that would mean there's going to be 4 payments of 100. So this is the payment field, this third one that we're skipping over. And the reason why is that when we have it set up as a table where we have year and amount, so the way we're expressing it here is year 0, year 1, year 2, 3, 4. Each row is an individual amount. So there's a 100 here, a 100 there, and so on. We want to find out the PV of amount. We need to know what's the present value of just that 100. And so we don't want to tell Excel that there are 4 of these $100 payments in year 1. There's only 1 of them. And so you'll see more of this. We'll use the payment field later on, but for now we need to skip over it with a double comma. There's another function that we're going to see today called NPV, and it's another one of these beautiful shortcuts like the rate function was last time in class. You'll remember that last time in class we were solving for the unknown interest rate by changing it around a lot of times, and there was, I showed you the goal seek tool up in the toolbar that automatically found for the correct interest rate that would give you the sum of the present values equal to 0. Well, this NPV function is something that's similar where you include a range of values and it automatically calculates the present value of everything that's already in the future. And so I'll demonstrate how to use that function today, but there's something very important to remember about this function. And like every exam, students forget this rule and points get taken off that are kind of needless deductions. I don't want to take off points, but it gives you the wrong answer. If you include a present value, if you include an amount that's already in the present into this function, then it's going to give you the wrong answer. You should only put things that are future money into that function, and you'll see what I mean by that when we apply it. All right, so here is today's first problem. Let me hand out the paper for this. I actually don't need to tell you anything about this problem. You know, just the cash flow diagram itself kind of gives you an idea of what we're trying to solve for. So obviously on this one you're solving for the present value, and you have some amounts in the future. There's an annual series there, and if you were going to solve this with the equation method, or if you were going to solve it with the factor method, there'd be a lot of different steps here. There would be the steps of taking that first annual series to year 1, and then from year 1 to year 0. You'd have to take the second annual series from this range to year 7, then from 7 to 0. There's some individual amounts, and so it would be a little bit dicey if we had to do it on paper a bunch of times. Does everybody get a copy of the paper? Is there enough? Okay, so start up Excel, And let's first do this with the PV function. Were there any extras in the handout? Thank you. If you don't have a computer with you today, then maybe just scoot next to someone who does have it. All right, so on the paper I tell you the columns you're going to need are year, amount, and PV of amount. Thank you. All right, so put those in here, year, amount, and PV. Oh, wrong one. All right. Here's the cash flow diagram. Year, amount, PV of amount. All right, and then the next step in translating the cash flow diagram to a table is you just have to put in how many years there are, 0, 1, 2, and so on. Rather than type them all in, you can highlight a couple that you've typed and then continue dragging it down. And you can see off to the side of where I'm dragging it, it tells me what number I'm on in the series. And so I can stop when I get to 16 because that's the last one that's on the cash flow diagram is 16. Okay, then you just type in the amounts. We don't know the amount in the present, so we're going to say there's no given amount there. It's an unknown at this point. Year 1 has 0. Year 2 has 12,500. That continues a couple of times, 4 of them. And there's 0 and 6 and 7. So follow along. You can translate that cash flow diagram into a table. Looks like everybody's getting that pretty well. The next column we're going to call PV of amount, and that's where we use the pre-existing function. So just as a reminder, it starts off with the equal sign to tell it you're starting one of its formulas, PV, and then as soon as you put in the parentheses, it starts to prompt you with what the next fields should contain. We don't have an interest rate yet, so this problem has an interest rate of 7%. I need to go up here at the top and have I equals and then 0.07. You can put that anywhere. It doesn't have to be immediately above it. You could put it over to the side, just some location where you can refer to that amount, that interest rate, when you're doing your calculation. So equals PV, and now it's asking for the rate. I'm going to click on the location. What do I have to do to make sure that when I drag the formula down, it doesn't look in the wrong spot for the interest rate? Anchor it. Yes, and what's the symbol that anchors the cell? Dollar signs. I'm not sure why they chose dollar signs, but I like it. I can just press F4, and it'll automatically put the dollar signs in front of the B and the 16. That's quicker than typing them in. So I just press F4. There they are. Okay, so NPER means N. What row are we on? It's 0 years that we have to discount. So I'm just going to click on the year here. Okay, now I'm at the PMT function. This is where I have to be careful, because if I put an amount into the PMT function, it's going to think that there are however many n's there are of that amount. So let's say I get to year 2. If I put the 12,500 as a payment field, it's going to think there's 2 payments of 12,500. And that's not what I want it to do. What I want it to do is I want it to move 12,500 2 years backwards. I want to move it from year 2 to year 0. And so I have to skip over that payment field by putting in the double comma to prevent it from making that mistake. So I've got one comma, there's the other. All right, and now finally negative sign because of that flip that I was explaining earlier, and then click on the amount. And so this first one, it'll be 0, which makes sense because it's a 0 amount. So when you move it into the, you move 0 years, it's not going to be any different. But then I can drag that down by clicking on the green box and dragging, or I can just double click it and it will apply the formula all the way down. Okay, so let's look at these amounts and see if they make any sense to us. So 12,500, if you move it 2 years back, in terms of year 0, it's only worth 10,918. And that makes sense to us because we know money in the present is worth more than money in the future. So another way is saying that is this future money isn't worth as much now, today. So this PV of amount column, that's telling us what is the value today of those amounts in the future. And so if you look at the amount in year 3, it's less than it was for year 2 because it's moving at a greater number of years. Let me show you what kind of mistake you'll get if you don't skip over the payment field. Okay, so let's say that you had accidentally here, you're doing the PV function, here is the I value, you're anchoring it, you have N, and now instead of skipping over payment, what if I put this payment in here, I click there. Well, let's say I even remember the negative sign, but it's still in the payment field instead of, so it's thinking that there's 2 payments of 12,500 instead of moving the 12,500 2 years. And so this amount is unusually large, bigger than it should be. So let me fix it then. And the amount is even more pronounced if you get here where it's 16. So what if I forget the double comma for that one? The amount's going to be really big. $75,000 is the value of 16 payments of $8,000 each. That's the present value of 16 payments of $8,000. But that's not what I want. I want to know the present value of 1 payment of $8,000, not 16 payments of $8,000. And so that's why we put it in the FV field instead. Okay, so the question in the handout is, what is the present value of all of these amounts? If we discount all of these amounts, how much is it worth in year 0? So we have to add all these up. So sum, so equals sum, and then you just highlight the entire range, and you should get 78,000. 78,260. Anybody else get that same amount when you add it all up? Let me give you a moment to type that in. The function to add everything up is equals sum, and then you highlight the range like that. Enter. So this was a little bit of a lengthy process for us because we had to, number one, find the present value of each of these amounts and then total them. This built-in function Excel, the NPV function, does something kind of interesting. You just highlight the amounts, not these present value amounts. You highlight the original cash flow amounts, and it'll automatically account for this being the first one it sees. It knows this is year 1, this is year 2, this is year 3, and so on. And then for whatever interest rate you tell it, it's going to calculate the NPV. So let me show you that one here. This is part B of the same question, where it says to use the NPV function on Excel. So using NPV. All I have to do here is equals NPV. Now you'll see in the prompts it's asking for an interest rate. We're still using 7% for this problem, so I can just click there. I don't necessarily need to anchor it because I'm not going to be repeating this formula more than one time. It's just the one time I'm going to be doing it. Now, comma. Now it's asking me for a bunch of values. Here's the warning I gave you. Only include future values in this function. Don't include the cell that's the present value. So let's look at the cash flow diagram here. Future amounts started here at year 1. This 0 that's in the amount of 0 that's in year 0 shouldn't be selected. And so I'm going to highlight as the range just this amount and not including the first 0 there because that's already in the present. In other words, this function is only used for amounts that are in the future that need to be taken to the present. So I've highlighted those future amounts. I'm going to close the parentheses and then enter, and then it tells me 78,260. So it's a great function. But let's say that I forgot that warning. NPV, I have the rate, and then I just highlight these amounts, all of them, including the one that's already in the present. So maybe it would make you think, oh, it's not going to have an effect because it was 0 amount. It's not going to matter anyway. But if you thought that, you'd be wrong. Because what it does is it counts what row everything is in. And so what it's thinking when it sees 0, then another 0, is it thinks that this 12,500 is 3 years in the future, when really it's only 2 years in the future. So it's, in addition to seeing the amounts, it's counting the kind of the location of the amount. So that's why we have to say NPV rate 7% and then only include stuff that's in the future. All right. Any questions about this first example? Okay, I'm going to turn you loose on the second problem. I'm not going to tell you exactly what to do other than I tell you the columns that are needed here on the bullet point. It says use the following columns: year, years until year 16, amount, and FV. So there's a different column there that we weren't using just now. For this second one, here's our cash flow diagram. And the way that the FV function works is you're going to need to know how many years it is until year 16. So I'm going to stop talking and give you some time to think about that, and I'll be circulating around in case you have questions. All right, let's just review some of the key points here. First of all, what's the purpose of this? Why did I suggest you should add that as a column to your spreadsheet? Yeah, we need to have something ready to use for N. And if you look at the picture, just as an example, let's look at the cash flow diagram. This 10,000 in year 0, if we're trying to get it to year 16, our N is going to be 16. But it's in year 0 right now. So rather than typing it in manually over and over and over, it's just easier for us to have a column that corresponds to each amount. This 10,000 amount, we need to move it 16 years. This amount in year 2 of 11,500, it needs to go 14 years. And so if we just have 16 minus n, then that gives us the information we're going to have to use in the FV function when it comes to that. So here in the FV function, you'll notice I'm referring to the interest rate, anchoring it. The n is this secondary time column rather than the primary time column. Skipping over with a double comma the payment field and then the negative of the amount. So it works great, and then in the end, if you add it all up, all of these inflows and outflows, the future value is 3820. Let's talk about practically why would you need to know the future value. Well, let's say that you're trying to figure out how much all of this cash flow would be worth as a future sale in the future. Like, let's say you're going to sell your business, and this is what you anticipate for your business during the coming years. You know that you're going to get 10,000 today, and then you're going to have to make some investments and so on. If you're trying to figure out how much your business would be worth in year 16, this tells you that you could sell this cash flow, or it's a series of investments and revenues, for 3820 in the future. Unfortunately, there's not an NFV function in the same way that there's the NPV, you know, the net present value. That's kind of a nice, quick way of finding the present value of things, but there isn't a net future value function. Let's look at the third problem. In the third problem, you have a table, and you're supposed to use the rate function to find the unknown interest rate. And so that is year and amount. So 0 through 7. And we'll type in these amounts. And just because the red annoys me, I'm going to change the formatting to currency. All right, and then we use the rate function. So equals rate. Now, this is something we are going to be typing in manually. So it's 7 years of a payment that's 7,500. The present value is this, and should calculate the interest rate 4%. That's rounding it. We can get more precision by going here, and this little button, increase decimal, will allow you to see all the precision that's there. So it's up here under the number area, and you can either increase or decrease the number of decimals that are shown. We don't need to see that many, probably, but 3.73, that's good. Yes? The formula is equals rate. So the way that we use it is equal rate, and then n is just how many payments there are going to be. So there are 7 payments of this amount, 7,500. The present value is the negative 45,460. Enter. All right. Now the last problem isn't based on calculations. For the last problem, I want you to outline your solution strategy. So what it basically means is, let me see if I can have the cash flow diagram here. All right. Here's here's the cash flow diagram. I want to know what's your strategy for solving this. Now, let's say that you don't have Excel, because if your solution strategy, if you are using Excel, is very easy. Just put each amount on a row, and then you just saw what to do using the PV function. I'm talking about what if you have to use the table lookup factors. So here is an annual series and a gradient that has to be dealt with in years 4 through 7. Then you'll notice here's an annual series in years 9 through 11. So I want to introduce you to kind of like a pseudocode. You think of it as like a solution structure that then, once you have the solution structure figured out, then you can go and plug the numbers in and actually find the amount. So thinking about P/A, P/G, try and figure out where the amounts would be and how you would solve this, what your solution strategy would be. I kind of give you an idea on what I'm talking about here on the screen. We have to break it up into pieces. We've got some inflows and some outflows, right? So I'm saying these inflows in years 9 through 11, I'm going to convert that into some amount in year 8. That's just the way that a P/A works. Find P given A. Well, you can only move it to the 1 year before the annual series begins. I can't take it automatically years 9 through 11 all the way to year 0. I have to, first of all, step 1, take it as an annual series, 3 payments of which are all going to be combined to year 8. And then here you can see in step 2, I'm going to take that amount from year 8 all the way to year 0. And so then, for that step, I'd use P/F for whatever the interest rate is. It's not specified, but we would use for that interest rate n equals 8. So then where I have B and this dashed arrow there, that is effectively the amount that is from this annual series in years 9 through 11. I moved it to year 0, but I had to do it in 2 jumps. I had to first jump to year 8 and then from 8 to 0. So if that gives you an idea of the sort of thing that I'm doing, then you probably are starting to have ideas on how to handle this gradient. There's a gradient and another annual series. And so 2 different parts of it. So 2 things are contributing to C. This amount at C is partly because of the G, and it's partly because of the annual series. And so step 3, I'm saying take the 500 that occurs in years 4 through 7 and move it to year 3. And the way we do that is if you count the number of them, there's 1, 2, 3, 4 payments. So that's why we say n equals 4. And this is a P/A, meaning find the present value for an annual amount. Now, some amount in year 3 isn't really the present. So what we're doing is we're creating kind of like a new quasi-present. It's a different naming scheme for time, because the only way I can solve a P/A is to move it 1 year before the first annual series is effect. And so you see that 4 is the first time we had the 500, which means that the present, the so-called present, is actually in year 3. And then to get it to year 0, which is where I want it, I'm going to have to do another discounting where I'm P/F. But before that step, you'll notice I also took the gradient value. So here is 0G, G, 2G, 3G. So the G amount is 100, and the gradient has 4 years. P/G will find some amount in year 3. So there's 2 things that are contributing to the height of the outflow in that line C. And then the last step is just to take that amount at line C to 0. And so that is a P/F function. that a little bit smaller. You see it all. This seems really complicated. The first time you have to solve problems like this, it's kind of a nightmare. But you'll get so good at breaking these cash flow diagrams down to parts and moving money around through time that, trust me, a week from today, this kind of problem is just going to be really negligible for you. It'll be very straightforward. But if it doesn't make sense yet, copy it down, copy down what you've got, and try and study it. You know, look at it until it does make sense. And then come back on Wednesday understanding it. Let's take one final look at the announcements before we finish. What you're supposed to be working on. The homework assignment is due on Friday. You've already learned how to do some stuff on Excel today, so you might as well get an early start on that. You could probably solve the vast majority of the assignment already. No reason to delay. So I'll see you next time. Please bring your computer if you've got one available.